All right, so we're going to take a quick look at these equations just to review them real quick. Um, when I start looking at these, the big thing is I got to look where the arrow is, and a couple ways I can, maybe break this down a bit. But I look on the left side, and I see I have an even number of oxygens. Currently, the sulfurs are the same. But I look on the right side, I have an odd number. And immediately I think, okay, I got to fix that odd number. To fix it, I'm going to start by trying to double it. That's my first strategy. Okay, so I put a 2 in front of that. As soon as I do that, I'm like, well, I have 2 sulfurs now. Grand total of 6 oxygens, which is an even number, and 2 sulfurs. That means there's got to be a 2 that goes in front of this one. And at this point, then I go say, okay, what's left over? That's my oxygens. So on the right-hand side, I have 6 oxygens. Right now on the left-hand side, I have 2 from here, plus 2 times 2 is 4 here. Hey, 4 plus 2 is 6. I leave this as it is. Now, if I have to put a coefficient in front of the oxygen, it's going to be a 1. But normally I would just write, I would leave that blank. All right, then we move on to the second one. And be honest with you, it looks ugly. I find where my arrow is. There it is. All right. So on the left-hand side, I have a sodium, hydrogen, carbon, oxygen. And the right-hand side, okay, it's breaking it down. This one thing is becoming somewhat simpler. First thing that I see is that I've got on the left-hand side this 1 sodium, and on the right-hand side I have 2. So my first strategy is like, well, I know there's other stuff here, but let's try doubling this to start with. All right, and then see where that takes us, because I need to have 2 sodiums. So now I've got 2 sodiums on each side. And then I can look at my next thing. Well, next thing over here is hydrogen. I've got 2 hydrogens on the left side and H2. 2 hydrogens on the right side. So far, so good. Then I have to be a little bit careful here with the carbons and oxygens and things like that, because oxygen shows up everywhere. So I'm going to have to start just really counting oxygens and also carbons. So I look at this here and I say, okay, well, I've got 2 carbons on my left side. I've got 1 here and another 1 here, so there's 2 on the right. I have 2 times 3 is 6 oxygens, and I've got 3 plus 1 plus 2. 3 plus 1 is 4 plus 2 is 6. It's actually balanced as it stands. 2, and then again, if I have to put coefficients, it's a 1, a 1, and a 1. Notice that all this stuff down here that I've just shown in blue, or I've circled in blue now, that's me showing my work. Same thing this here. This is me showing my work. It's just jotting some numbers down so that I'm not carrying all of this in my head. All right, let's move on to the next one. All right, I've got aluminum, I've got copper 2 chloride here. First thing I look at is I see, oh, look, I've got 3 chlorides on the right-hand side. There's my arrow again. And I've got 2 on this side. Easiest way to fix that is to say, well, I got to get even numbers on both. 3, I'm going to multiply this one by 2. All right, so now I've got 6 chlorides. I need to have 6 chlorides here, so I'm going to go, well, 2 times what gives me 6? Oh, it's 3. And now I start chasing my aluminums. I say, oh, okay, look, I've got 2 aluminums on the right. Means I have to have 2 on the left. And I have 3 coppers on the left, which means I need to have 3 on the right. And I'm done. I have 2 aluminums on each side. I have 3 coppers on each side. And I have 3 times 2 is 6 chlorides here, and 2 times 3 is 6 chlorides here. And then the last one. Got this sort of ugly looking thing. Now, if you desperately don't like the way this formula is written, this is an ethane thiol, you could rewrite this showing less structural stuff. C2H6S. Chemically, it doesn't show me much about what the structure of this thing is, but it does show me what's there. So I could rewrite it that way. My first step then, this is hydrocarbon combustion, and we'll go back and look at the classifications for the others in a second. There's my arrow. It's hydrocarbon combustion, so my first step, I got to look at hydrogens, balance those, and make sure I've got an even number of waters. So 6 hydrogens total, or 3 plus 2 plus 1 is 6. Means I would have a 3 in front of the H2Os, but that's not an even number. To fix that, I immediately double this one. So this is going to be a 2. All right, and so now 2 times 6 is 12, which means I have 12 hydrogens, and so 6 times this 2 here will give me 12 hydrogens on the other side. Lovely. Next step is carbons. I have 2 carbons on the left, which means I need to have 2 of these CO2s, so I'll have 2 carbons on the right. Did I do that right? Initially, it looks like I might have, but as I say that out loud now, I'm like, wait a minute, I have 2 times the 2, so I have 4 carbons here. So that means I'm actually going to need to put a 4 here. So be careful with that, right? I put this coefficient out front. I have to make sure I actually remember to deal with it all the time. So I have 4 carbon dioxides, lovely. And now that also tells me I have 2 sulfurs on the left side, which means I need to have 2 sulfurs on the right-hand side. And now I need to figure out the oxygens. So I have a total of 8 in the carbon dioxide, total of 6 in the water, and total of 4 here. So 6 plus 4 is 10, plus 8 is 18. How do I get to 18? Well, 2 times what gives me 18? Oh, it's going to be 9. So I'm going to put a 9 here. And then I just need to classify it. So I'm going to just circle that where I was kind of showing my work a little bit here so that that's not as confusing, maybe. And let's classify these guys. So the very first one, I start with 2 things and I end up with 1. So what that probably tells me is that this is some kind of formation reaction. Now, I'll be honest with you, I would not be able to mark you wrong if you told me that this is combustion. It is possible that this is combustion as well, right? I'm combining something with oxygen. So if you wrote down that this was combustion, I couldn't mark it wrong. If you said hydrocarbon combustion, then it would, because there's no hydrogen or carbon there, but it is combustion. All right, let's move to the next one. I start with 1 thing, and it turns into 3. And what this tells me is that this is some kind of, it's not simple decomposition, but it is some kind of a decomposition reaction. In fact, this is what happens when you put baking soda into cookies, and then you put the cookies into the oven. You end up taking the NaHCO3, that's your baking soda, and it breaks down into sodium carbonate, which is just along for the ride, steam, water vapor, and carbon dioxide. And it's the steam and the water vapor that actually help your cookies to rise. Oops. All right, then we move on to the next one. And here we have aluminum by itself and copper with chloride. And after the reaction happens, the aluminum now is with the chloride and the copper is by itself. This is a single replacement reaction. And the very last one here, I already said this one, but we're taking something with carbon and hydrogen, which makes it a hydrocarbon. Even though there is sulfur there as well, it could have nitrogen, it could have phosphorus. I'm combining it with oxygen and making carbon dioxide, water as a gas or vapor, and then I've got the sulfur. It's got to combine with oxygen as well, make sulfur dioxide. This is definitely hydrocarbon combustion. Oops, combustion. There we go. Now again, just so you can see, our other type of reaction that we could do, a little bit harder to write in this program, but I'll just show you the other type here in words. So let's assume with this other type, I have aluminum. Make sure, no, let's go this way. So, wow, learn to spell. Sodium phosphate plus, ooh, try that again, phosphate plus silver nitrate. This is going to turn into, if this is a double replacement, double replacements are easy to write with the words, and maybe sometimes that helps. The sodium is going to switch places with the silver. So we're now going to have sodium nitrate, and the silver will switch with the sodium. Silver phosphate. And there we go.